Alright, so I guess I will switch it over to my screen. And it would be a good idea to turn on the display capture. That would work. That's weird. Homebrewer's message just got flagged. Because you used the term Portswigger. I don't know why that happened. Okay, so I think can I post a poll in this? I'm still learning how to, do this stuff. Maybe I have to be a better Twitch person to post polls. But I thought I would ask you guys. So on Twitter, when I originally announced this, because this is the this is 1,000 students of my Privest course in a month celebratory stream. So thanks for joining us. I posted on Twitter saying I'd do this, and I posted a poll. Everyone decided on Portswigger. They want to see some more content for that. And then I asked, okay, what do you want to see in Portswigger? And I think 2 people responded. one vote was for SQL injection, and 1 vote was for server-side request forgery. So I figured I would do both. But which one would you guys like to see first? So just, I don't know how to do a poll. So I guess we will... Yeah, I tried... I couldn't figure out how to do a poll, but it looks like SQL's already won. So Homebrewer's got the lone vote for server-side request forgery. All right. I mean, SQL injection is a good place to start. And I figured I would also... so, like, SQL injection is complicated, right? It can get really complicated. So I thought what would be a nice way to start would be something that I learned quite early on in my career, not just in InfoSec, but as a dev. And that's just, you should learn how to play with SQL. Because obviously, if you know your way around SQL queries, then injecting into them becomes, slightly easier, I would say. So what I'm going to show you is 2 really simple Docker commands where you can create a phpMyAdmin instance that's fully workable. It's connected to a MySQL database, and you can log in and just create tables, run queries. So I have them here. So we'll do this. I think I deleted the... let's clear that. So the first one... I'm just going to run it. You can see it on the screen. I'll put it on the video as well. But docker run --name MySQL. And then I set an environment variable, MySQL _root _password equals just the word password. And then -d MySQL :latest. So all that's saying is, okay, just use the latest version of MySQL Docker. So that's set up that. So now we have a MySQL server running. And the next command is the phpMyAdmin. And the difference here is you can link the phpMyAdmin instance to the MySQL instance. And then there's a bit of port forwarding here. So yeah, sorry if you can't see that. I'm not sure if it's easier to make my screen big, make text bigger. Here we go. Okay, so it's Tmux does not like that. Okay, yeah, that was not good. I'll post the links. So what we can do now is go to localhost 8888, and we get phpMyAdmin. I can log in with the root and the password that I set, and that's it. Like, other than installing Docker, That's all you need to get a fully working MySQL database with a connected phpMyAdmin instance. So from there, you can go and create a database. So let's create a database called Tiberius. We'll choose, what's a good UTF one to have? I think the bin ones, yeah. Oh no, Unicode, sorry. We can create that. We can create a new table. Let's call it users. We'll have 3 columns. And then let's say we'll have an ID, we'll have a username, and we'll have a password. The ID is going to be an integer. It's going to have a length of 5. We'll give it the primary index. Should be fine. Make it auto increment. And then for these, I'll just set some, so I'll set them to varchar, and with a length of 255. Okay, so now we have an empty database, empty table called users, and then you can just click insert, and we can start putting values in. If you set ID to auto increment, then you don't even have to worry about putting a value here. So we can have admin password, and then let's just say tib and password 1, and then you just click go, and then if you go back to browse, you can actually see, so we have those 2 tables, those 2 rows in the table. So that's like how you can set up the environment, and then if you go to this SQL tab, you can start doing things. So the default query is select all from users where 1. What I'll do is I'll check these 2. That's just useful to have. If you click go, yeah, it's a plain text password, but who cares? So all I did was select all users where 1, right? 1 is always 1, so that's going to be fine. And so it's showing both. And then you can do things like, username equals tib, and click go, and then it'll only show that. And so if you, I can zoom in with this browser. Let's back it out a little. Is that better for everyone? So if you've never really understood SQL injection, this is probably a really easy way to show it. So imagine that this value has been taken from a login form, right? So you've logged in with your username and you've entered a password, and say you have this query, password equals password. Well, if you're in attack, you don't know the password, right? So it's whatever. So if you click go here, then it's going to return an empty set. So 0 rows, because there's no user in the table named tib, where the password is this. So with SQL injection, if you were to SQL inject into the username field here, what we could do is we could say, okay, well, select all from users where username is tib, and then we're injecting a apostrophe, and then a space, or 1 equals 1, and then if we put a comment in, if you'll notice as well, this is the great thing about phpMyAdmin, in my opinion, is it shows, the syntax highlighting. So you can see that these are the structure of the query. So this is colored purple. Strings are in, looks like maybe brown, and comments show up as well. So in this case, if we click go now, we'll actually get both rows back. Because this query, instead of relying on just the username, we've put this all 1 equals 1, so it's going to return every single row from the user's table where either the username is equal to tib or where 1 equals 1. Since 1 always equals 1, we're always going to get everything back. So I think that's just a nice way of playing around with it, and it certainly is, if you're trying to do SQL injection, it's kind of useful to know exactly what's going on behind the scenes. And you can test stuff like unions and everything, so we'll do that later as well. Okay, so let me go to Portswigger. We'll go to view all materials. And I'll scroll down to, we'll open up the SQL injection here. And we will just read down. Okay. So we'll start off with the simple stuff. So an SQL injection vulnerability in the where clause allows retrieval of hidden data. Okay, so this is actually kind of basically what I just showed you, right? So they're using or 1 equals 1. So we'll open this lab. This lab contains an SQL injection vulnerability in the product category filter. When the user selects a category, the application carries out an SQL query like the following. To solve the lab, perform an SQL injection type that causes the application to display details of all products in any category, both released and unreleased. So the query is going to take the category that we give it, I think, from the URL, and it's also going to have this hard-coded part and released equals 1. So it's only going to show products from where the category matches gifts, or whatever we give it, and where the product has been released, basically. So we should be able to easily solve that one. Okay, so if I click on accessories, okay, so that's in the URL. So this accessories is basically the same as what this gifts thing is here. So it's fetching something from the database. So we can always just start out by putting an apostrophe in there and seeing what happens, and it gives us an internal server error, so that shows that, you know, potentially there's some SQL injection, or potentially the back end is reading this and it's going wrong. So if we try or 1 equals 1, and with these things, obviously always put a comment at the end. You sometimes have to follow it with a space. It really depends on the database. I generally try to follow it with a space and something else. And the only reason I do that is because you don't know what the server is processing this string, because this string gets passed to the web server first. And so if the web server is expecting certain values, it might process the string first. So for instance, if we would just do -- space, it might trim the string, and so what would actually get sent to the database is just that. And like I said, sometimes the space is important. So I always try to end SQL injections, even if you have a comment, I always try to end it with some non-white space. And so let's see what that does. And okay, it solved it. Good. All right. So it looks like in this case it loaded absolutely everything from the database. So we solved that lab. Again, that was like a basic one, but hopefully that explained it with my example from phpMyAdmin. Let's go on. So that was that solved. Login bypasses. Again, this is very similar to what I showed in phpMyAdmin. So in this case, though, we want to log in as the administrator user. So we might have to inject into the password field, or possibly set the username. Okay, so I mean, let's just try that first. Okay, so we have injected. So administrator, and it might just be an issue of this, because I'm assuming the query looks like something like select all from users, where user equals whatever's in this box and password equals whatever's in this box. So if the username comes before the password, we should just be able to comment out the rest of the query, put some nonsense in there, and then hopefully, yeah, there we go. So in that case, if we go back to here, what we did was the query looked like something like this. Okay, so this value was taken from the first input field, this value was taken from the second input field, and obviously in our case, if we wanted to match the admin user, we would have to type the word admin, and the password as the word password, right? And then you would get nothing back. Oh, because I missed out the and. So that's important. So if we click go there, we get one row back, right? But in this case, since we know that we suspect the username field comes before the password field in this query, if we just want to log in as the admin user without knowing the password, then obviously we inject into there, and then we immediately just leave a comment. And so that's going to turn exactly the same data, but it's doing it without matching the password. So we just care about matching the username. And again, see, we get the row back again. So hopefully that made sense. Okay. So I think this is, yeah, union attacks. Okay. Right, so for union attacks are pretty cool. So what I'll do for this is I'll create a new table, products, and we'll have an ID, and we'll have a name, and let's say we just have a price, okay? So the ID again is going to be auto-incrementing. The name is going to be varchar 255, and the price we'll put as a float. I can't remember if a float needs, no it doesn't, okay, good. Alright, so we'll add a book for $1, and we'll add, I don't know, what else, TV for 100. And then we'll click go. So we need two things. So now we have two tables, and you can union these tables. All that means is it's going to effectively join the tables together, and well, I'll show you what I mean really. So we'll do select all from products, union select all from users. Okay, so what it's done is it's effectively unioned the tables, so we get every single column, sorry, we get every single row, but from both tables. Now you'll notice that because we selected from products first, the username and the password appear in the name and the price columns. Okay. Now if we go back to the users table and we add another column after password, and this is just going to be like enabled, right? And it's going to have a length of 1, and we'll just leave it as 0. If I go back into the products table and we do that SQL query again, so actually it's here again, union select all from users, we get an error. And that's because it can't union these tables together, because the users table has more columns than the products table. Okay, so to get around this, what we can do is we can actually, instead of saying we want to select all from users, we can just select as many columns as there are the products table. But obviously doing this blind, you don't know how many there are. So what you can do is you can reference tables, instead of referencing them by name, you can reference them by their ID, like an integer ID. So if we do that, we get an error, because obviously now we're selecting 1 from users, so we're selecting the first column. And that's only selecting 1. Obviously product has 3. So again, we'll say, okay, let's select 1 and 2. And that didn't work either. But as soon as we do 1, 2, and 3, there goes my kitty again. It works, okay? So in this instance, we got the union works. So we got the first, second, and third rows. Columns. Okay. Another way of doing that is you can do null. So if I do null and null, it's going to error. it's actually going to tell us the reason as well. If I go back up to the top and do null 3 times, it should work. Okay. You'll notice that in both cases it didn't actually select the columns, it's just selecting the numbers, right? So in order to do that, we would have to try and figure out, we'd have to try and guess the column names. And so that's an attack you can do as well. But hopefully that explained kind of SQL injection with union attacks. We'll use it to solve this lab. So there's a SQL injection in the product category filter again. The results from the query are returned in application response, so you can use a union attack to retrieve data from other tables. To do this, you first need to determine the number of columns that are being returned by the query. And to solve a lab, perform an SQL union attack that returns an additional row containing null values. Okay, so that's basically what we were doing before. So we can do union. Actually, it's probably going to be a semicolon. Sorry, not semicolon. Apostrophe. Union select null. And we get an error. Try it with 2. Try it with 3. And there we go. And we solve the lab. And you notice here I didn't select them from a table. You don't need to. If you just run, if we just run select null, 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 you'll get some imaginary table, right? So we're not selecting from anything here, we're just selecting null, null, null. The same thing should, I believe, work with 1, 2, and 3. Yeah, okay. So that's just something you can do with SQL. So we've basically figured out, though, that this, whatever table that has all these products in it, has 3 columns. Okay, so finding columns with a useful data type in an SQL injection union attack. So let's go back to here again. So if we go to the products table and we select all from products, union, select, let's do null, null, null from users. We get that. You'll notice that the first column, so the first column of both the users and the products table was an integer. So this works fine because you can load nulls into integer columns. You can also load numbers, obviously, you know, integers. You can possibly, I'm not sure, we'll see, yeah, you can load decimals, but I don't believe you can load strings, or you can, okay, so you can load strings. Did I set that up wrong? I didn't, okay, my demo didn't work. That's interesting. Because usually what happens is that rejects it, but we'll go with this because this actually has a better demo. So basically we need to find a column containing text data. So again, we will do the union attack. Select, so we'll do null, null, null. Oh, and I should probably leave a comment. So that worked. So let me just read on this. So yeah, basically what they do is they put a string as the first value, a string as the second value, a string as the third value. And so if we do that, so if we change this first null to an A, we get an internal server error. So that's what I was trying to show when I was doing this. I'm guessing maybe MySQL does something weird with that. But what it's trying to do at the server side, it's trying to load a string A as an integer or some other value, and it can't, because obviously it's trying to load it into a database field that's not a string, or not a varchar or a char or something. So what we'll do is we'll move along and we'll put it in the second column, and in this case we get it. So it looks like this second column references the name of the field, so the name of the product. Okay, and you can tell that because it's put it in this same column. So it says make the database retrieve the string this, so that's easy. We can just swap out the A and we get that. Okay, so now we can actually use it to grab data from other tables. So this is where it gets interesting. So we're going to do the exact same thing again. We're going to figure out how many columns are in the users table now. And sorry, we're not going to figure out. We're going to figure out how many columns we can union. And then we're going to union some columns from the users table, specifically the username and password fields. So I'll select that one. So we'll do union, union select. Let's try. I'll do with nulls. Let's try 3 again. We get an error. Let's try 4. And maybe 5. Could be 2. There we go. It was 2. All right. They confused me with the last one. Okay, so we know that the products, or whatever this is, this has 2 columns, and you can probably guess that one of them is going to be probably for the name of whatever this is, and then the second one's going to be this big description. So what we can do is we can add. So selecting null from users, and so that still works because that's fine. So now what we can do is we can just replace the first null with username, and if we scroll down we get some usernames appearing, right? Carlos and Wiener, and then administrator, and then we can replace the second null with password. So if for whatever reason this wasn't this big long description and it was an integer, and we were using whatever backend database didn't like loading strings as integers, this obviously wouldn't work, because as soon as I type password in there, it's loading a string, and it would give an error. So what you would do is you could either concatenate it here, or you could just do one query to get the username and then change username to password and get all the passwords as well. But we will just put the password field in there. So there's administrator and password. In fact, let's see if we can. I wonder if we can do a concat. So let's try username password. Let's see if that actually works. It does. All right, cool. So actually, let's assume that this second column is not a string-based column, so it's maybe an integer, and for whatever reason we can't load data in it. So we can only load data into one column. So in this case, what we're going to do is we're going to use the concat function, and we're going to concat username with, and let's just load the string colon, and we're going to concatenate the username, the string colon, and password into this first column, and then we get administrator and this password here. And so I think to complete the challenge you need to log in as the administrator. And yeah, in it's plain text passwords, just to make it slightly easier. Obviously, I'd like to say most web apps or web app databases these days don't just have plain text passwords, but You never know. So yeah. Okay, so we did that one. We just did this one, I think, right? Let's check. Solved, yeah. Okay. Retrieving multiple values with a single column. Oh, look, I skipped ahead. I was getting way ahead of myself. So this one actually, I mean, this might use a different database. The concat, I believe, is MySQL. But Portswigger have this cheat sheet here. So yeah, MySQL is concat, so it has a concat function. But you can also do it with by putting a space. So let's do this one, because if this isn't MySQL, this could be Postgres or Oracle. They all use different things. So let's try this one. Oops, I need to do a union. Select null, null. Oh, and I probably need to actually end it with a comment. All right, so there's two. So in this case, if we select null null from users, and then we change this first one to a username, we get an internal server error, but I'm guessing this one, this second null, we can switch to username. Yep, so we've got all these. So we can try using concat. Okay, it was concat. All right, so same thing there. Administrator, and log in with that. But this SQL injection cheat sheet that the Portswigger have is really really good, so you can see all the different ways of concatenating with different databases. You guys see the all the text okay, by the way? I just want to make sure. I'd imagine you would have commented by now, but okay, so we did all that, because I can switch to burp. I really should probably be doing this in burp, but I figured while it was all part of the URL, it was fine. So maybe I'll switch to burp. Okay, so we did union attacks. Examining the database. Querying the database type and version. All right, so this is on Oracle. Okay, so I just need to add this as a target. Okay, cool. All right, so let's read this. Again, it's in the product category. You can use a union attack to retrieve the results. So we want to display the database string. Every select statement must specify a table to select from. Okay, cool. So you can use the dual table. Yeah, okay. So let's set that, and let's go down to here. This might actually be worse because it's so small. I'm not sure I can change it without restarting my session. Hang on, it's in user options somewhere. I could set it to 18, or possibly. Oh, that might work. Yeah, look at that. Okay, we didn't have to restart. All right, let me boost it up to try 24. Okay, how's that? So that should look a lot better. All right. So what I did there was I selected URL encode as you type. That's just so we don't run into any issues. So if I go back to the example they had, you can union select from dual, right? So actually I can't even copy. So union select null from dual. Okay, so we tell server error. Let's do that. So we know it has 2 columns. Whether we can render it, let's have a look. And there we go. Okay. So we know it has 2 columns. So if we go back to the cheat sheet, which is... Where did I put the cheat sheet? I think I closed it. I'm going to put it all the way over here. Go back to the cheat sheet. To get versions from Oracle, select banner from this database. So in this case, we can just say, okay, let's try selecting banner from that. And it solved it. Yeah, there is the banner, right? So core 11.2.0.2.0 production. Okay. And so that was Oracle. We'll do it again on MySQL and Microsoft. So we'll access the lab. By the way, the reason I'm choosing gifts is only because it's the shortest one. So I didn't want it to take up too much of my screen, but this will work, or it should work, with any of the ones that you choose. Okay, so in MySQL and Microsoft, so NSSQL, it's the same thing. It's select add version. So in this case, we should just be able to do... I need to turn on URL encode as you type. Union select. So we'll do first, let's try with 2. That looks like it worked, right? Because if we try it with another one, it's gonna... Yeah, okay, so 2 is good. So in this case, we should just be able to do version. Let me render it, and it should hopefully... Yeah, there we go. So there's the version 8.0.15. And we solved that one as well. Okay, so we did those 2. Listing the contents of the database. So yeah, in most databases you'll see there'll be an information schema. So if we go to phpMyAdmin again, you'll see this is the information_schema database. And if I load that, you can see a bunch of stuff, right? So if we go down to tables and we click on that, we'll see there's a few tables in here. If I scroll, so I think if we go all the way to the end, it should show, or maybe not. Where is the table name? Table schema, MySQL. Hang on, I'm just going to zoom out a little bit. Okay, yeah, I think we missed it. So if I go back a little further, maybe go back to that. I've lost the table, but anyway, the table should be in there, the ones we created anyway. Let me just make sure it's make sure I'm reading it. Yeah, it is in tables. There should be, yeah, 2 tables for the ones that we created. I'm just not sure why they're not appearing. It's possibly something I'm doing wrong. There they are. All right. Let me sort it again. Right, okay. So remember there were 2 tables we created? I guess I was missing it because it was sorted by alphabetical order. So the information underscore schema database has a tables table, which I have lost again. It's somewhere in here, which lists information about all the tables, including tables within itself, right? So if we click that again, this is information about all the tables within the information schema. So it's kind of self-referential there. But these are the 2 tables we created in the database Tiberius, right? We created products and users. And you can also go to columns. And columns, you might have guessed, contains information about all the columns in all the tables in all the databases. So if we click table schema again and again, we get, okay, so in the database Tiberius, in the products table, you have a name column. In the users table, there's an ID, there's a username, there's enabled, there's password, right? So this is basically all the metadata. So this is what you can query. And this is, if you're running SQL map against MySQL, MS SQL, and you have error-based stuff especially, this is how a lot of the time it'll get the information. So something worth knowing, I think, anyway. So let's list the database contents. Okay, so database contains a table that holds username and password. You need to determine the name of this table and the columns it contains. Then retrieve the contents of the table to obtain the username and password. Okay. I'm just going to stop to have a quick drink. Okay, so let's send this to Burp Suite. There it is. Send to repeater. It's not alcohol, it's iced tea. It's actually been very hot here today, so right, we're going to URL encode as we type again. And firstly, obviously, first thing we're always going to do is we're going to try and determine how many columns we have to play with. So let's try that, and it looks like we have 2. Let's just check. So if we do 3, we get an internal server error. Great, so we have 2 columns. Hang on. So if we go back to this, so we want to basically list all the tables, right? So if we go, and this is where this can come in interesting. It tells you here everything about the table catalog, but we can just get the same information from phpMyAdmin. So if we go to the tables, what we really care about is firstly the database names, and we can get the table name. So we can get table underscore schema and table name out of this. So what we'll do is we'll select table underscore schema and table underscore name from, and I always forget the exact information underscore schema. There we go. Okay, so hopefully that works. It did not. Probably because one of these is not a string. So let's try. Okay. That's interesting. Oh, I am an idiot because obviously information schema is a database. So we need to reference the table. Okay. All right, there we go. So hopefully, yeah. So here we go. We have a list of all the tables. Well, technically all the databases, right? So PG catalog, it should be a database. So if we scroll down here, we can look. So we're trying to figure out. We're trying to find the users table. Let me actually load this in the browser and see, because I feel like it's my rendering engine is hiding. Yeah, my rendering engine was hiding everything. So this is what we want, right? So there's a database called public, and it has a table called users underscore PCCXXP. Okay, so now we want to figure out what columns this has. So what we'll go back to phpMyAdmin, and we'll go back to the columns list, and you can see. So column name is column name and table name. So we don't really need a table name because we know the table name is users. We want the column names. So in this case, we can adjust this. What we'll do is we'll do column name, and we'll just set this to null. And we don't want information schema.tables now. We want columns. And then we also want where table name equals, and then what was the table name we actually got? It was that. So I believe let's have a look. Right, yep. So I didn't need that. Didn't need to scroll down any further. So obviously it's union everything, so you'll still get all this stuff, but we see we have a username underscore whatever that is, and a password underscore whatever that is, column in the database. So in the the users PCCXXP table. Okay, so now what we can do, finally, and what I'll do is I'll actually that was username, wasn't it? So we'll copy this. So we want to select the username, and there's the password. Username and the password from, and this is where we need to change this. So the table was public, so it's public dot users underscore PC blah 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 blah. It depends on how it's passed. Yeah, it could work if I just put an equals. I tend to try and URL encode all the good stuff. Equals is a special character for parameters. So I mean, technically, this parameter shouldn't end unless it comes across an ampersand, which didn't work because it was encoded. So yeah, you should be able to put an equal sign in there, but it doesn't really matter right now. And it works. You can guarantee it's going to work this way anyway. Okay, so what we did there was we selected username and password, these weirdly named columns from the public users whatever database. So if we send that, this should be our final test. So we get administrator and this password. So I'm going to go administrator, copy this password, and we are going to log back in to solve the lab. So that's kind of, I think the OSCP kind of goes over stuff like that, right? Kinda. It goes over like some basic SQL injection. I remember doing union enumeration on the OSCP. So this, I guess, takes it slightly further, and is the same kind of method that SQL map uses as well. So SQL map will use the information schema table. Okay. All right. Equivalent to information schema on Oracle. So Oracle doesn't have an information schema table, but it has this all tables thing. So we will inject into that. Okay. Let's go back here again. URL encode as we type. Okay, so we're going to union select. So remember in Oracle you have to actually select from a table, but you can use the table dual. And it looks like there are 2 columns. Let's again just double check, and there are. So we have 2 columns. So we want to select, can list columns by querying all tab columns. Okay. So I guess let's just check the cheat sheet, because it's probably table name, but let's table name. That looks good. Yeah, okay. So I'm going to open this again in my browser, just because the rendering engine in Burp is a bit buggy. So I guess it's going to be users, but there we go. It's going to be that one. I know it's that one because this is what Portswigger does. Okay, so we've got the table name. So now we want the column name, and there's all tab underscore columns. So I'm guessing all tab underscore columns. I'm guessing it's going to be column name. From all tab underscore columns, where table underscore name equals that. And that's taking a while, which tells me it probably worked. So let's, again, I'm going to load it in my browser just to make it a bit easier. There it is, username and password. Okay. And so now we can just say, okay, we're going to use the username column and the password column from this table. So we can scrap literally all of this. And that should work. Let's do administrator. There it is. So that was exactly the same thing, slightly less steps, but yeah, not too difficult. Obviously, I'm doing this manually just because I feel like, you know, it's easy to explain as well, but in a real world engagement, you wouldn't do any of this. you would just fire up SQL map. So yeah, there's only a few occasions where I've had to, do manual SQL, and that's simply because the query was the backend was so complicated. It wasn't worth SQL map, or in one case it was impossible to do something with SQL map, and that was because it was a super blind SQL injection. I'd imagine Portswigger are okay with running it. I don't think they want you to run it like with a massive amount of threads, or massively aggressively. But there are some labs where you legitimately have to send like almost 10,000 requests. For instance, one of them has you brute forcing a forgot password code. So they design their labs to be pretty resilient, but I'm sure you can SQL map. I should say I'm sure people have done it. So yeah. Okay, so that was all of that. So we did that. Blind SQL injection. Here we go. So this is the fun stuff, really. Blind SQL injection is awesome. And by awesome, I mean a pain. So in this, in the previous ones, we had results from the SQL query being returned in the page, right? So that's technically done in either error-based, stack-based, and union-based. When you have blind SQL injection, error messages aren't returned, other than sometimes generic error messages. But more importantly, content from the query that you are sending isn't returned. So you can't just say, okay, select username from users and have all the usernames appear. But you can still extract information. It just takes a heck of a long time sometimes, which is why blind SQL injection is just awful. But definitely worth doing. So in this case, they've actually given us more information just because they don't want us to enumerate all this stuff. So there's a different table called users with columns, username, and password. You need to exploit the blind SQL injection vulnerability to find out the password of the administrator user. So we will do that. Let's try sending this to repeater. And so in this case, I believe we're looking at the welcome back message. So I'm just going to set a search down there. So that's always going to say whether the welcome back appears. So I guess what I could do is C or 1 equals 1. I should put and 1 equals 1. Okay. And we get a match. Okay, so that's probably good. And now if I change the and 1 equals 1 to and 1 equals 2, okay, we still get a match. So that definitely did not work. I'm guessing they want us to do a union. So actually they do give information here, right? Select a where 1 equals 1, which we can do. One. Yeah. Okay, so in this case we get a match still. If I change this to a 2, hopefully we still get a match. Let me see. It's possible sometimes you want to take out that. No. Keep clicking on the wrong browser. Oh, hang on. because I'm injecting into the wrong place. All right, this is a tracking cookie. So this was completely meaningless. So in this case, we should be putting it down here. Okay, so there's no welcome back there. And there's no welcome back there, so there's still something going on. I think if we remove that, maybe no. Let's go to the cheat sheet again. Conditional errors, conditional responses. This is a weird one. I'm just going to check my syntax. Could be. Let me just double check. Okay, I'll refresh the page. I'm going to send it to repeater again. Okay. So if I send that, we get a welcome back when the query's right. So we know that much. So something is happening with the query. Union select. And I should have encoded all that. So it's possibly okay. No, that worked. some reason. No, and then we still get welcome back. Oh, I did. Is that what I did last time? No. Yes, I did. So it should be. Yeah, I mistyped last time. I put an and. That was on me. But for some reason it's still not working. I'm wondering if is it a. Okay. No. Is it a thing like that? Okay, I'm going to go back to the start again. So when the query is valid, we get a welcome back. So if I do that, we don't get a welcome back. If I do this, why did it turn off that? It turned off my URL encoding. And so that's still failing. Let's try and at least get it working again. Yeah. I have done this one before, and now I cannot for the life of me. If the query returns any rows, there probably is a hotkey for send, I just don't use it. I'm terrible with hotkeys. Okay. So, hey, we got it. Okay, I don't know what I did, but that is now working. So when we have union select A where 1 equals 2, you get no matches for welcome back. If we change that to 1 equals 1, we get 1 match. Okay, I do not understand where I was going wrong with that. Weird. Okay. You didn't miss, I mean, you missed an hour, but it'll be recorded and put on my YouTube, so you're good. Okay, so we've got the query working, so now we need to do some enumeration. So we know there is a users database, we know that there's a column username and a column password, and we know that there's an administrator user. So we can check that though. So we're going to select, well actually, I'll go back to this. So you can use these awesome queries, and we'll do this, we'll copy, copy that, so select a from, right, select a from users where username equals administrator, and we can delete that. And so this should return 1 row, so we get a match. So this tells us that there is a username administrator, there's a user called administrator in the users table. If we were to change this to administrator 2, we should get 0 matches, which we do. Great, okay. So we want to enumerate the password. So the first thing we need to do is figure out the length of the password. So we can do that. Yeah, there is definitely a way of doing it, I think. Hang on a minute. Center repeater, we've got all that. Control space, okay. Alright, so we'll do and length password. So the length of the password field, let's say, is greater than 0. Control space, nice, that worked. So, okay, so we get a match, which means that was true. Let's just double check that. So we'll change that to less than 0, and we get 0 matches. So that's great. So now we can start enumerating. So let's see if the password is greater than 10. And it is, because we get a match. Let's see if it's greater than 20. It's not. Okay, so let's see if it's greater than 15. It is 17, 19. Okay, so it's 20, right? So equals 20. Yeah, okay. So we know that there's a username, a user called administrator, and they have a password which is 20 characters long. So now we can start enumerating the actual individual characters of the password. Now SQL map is really good at this. It can do something called a binary tree search. We're not going to do that. We're going to just automate it and brute force it with intruder. But what you can do is you can do substring. So basically we're going to select the first character out of the string password with an offset of 1. And we're going to see if that is equal to A. And it is not. So basically it explains it here, right? So this is how SQL map does it. It basically, because all characters are represented by effectively a number anyway, you can use greater than. But we're just going to brute force it. So what I'll do is I'm going to send this to intruder. I'm going to clear this out because all we care about is this character here. And we're going to go to payloads. So I know for a fact that all the passwords in this are comprised of either lowercase letters and I believe some numbers. So what we want to do though is we want to grep for welcome or welcome back. And if we start attack and then sort by welcome back, there we go. So we got a hit when the character was, I think that's a 1. Yeah, that's a 1. Okay. So the next thing we want to do is we'll go back to this and we'll put the 1 at the start. Okay. And then we'll change this to 2. Because I believe in substring this is the offset, so we're saying basically no offset. We're going to start the first character and we want to see 2 characters, right, of this, whatever this is. So if we start the attack again, there we go, we get an M. And basically you just repeat this. I'm not going to do the whole thing because it's 20 characters, but we'll do a few, you know. So you basically just keep doing it. So that's what an I. And every time, make sure you add the letter that was enumerated in the previous step. So you add it before the A, and you increment the last option here by 1. And eventually, you will get the whole 20-character password out. So that was a 5. But again, I'm not gonna solve the whole thing because it would just be a waste of time. You can see what's gonna happen. Okay. This is kind of similar. So this is just basically triggering an error instead. So before there was a difference in the HTML where it would say welcome back. In this case, it triggers an error, but the error doesn't spit out any information. It just causes an internal server error. In this case, we're trying to divide by 0. But effectively, it's exactly the same attack as before, so I'm not going to show it. It uses obviously a slightly different syntax here. But other than that, it's completely identical. You would still use the substring attack. And other than that, you're just basically grepping for internal server error. And again, time delays, what we'll do is I'll show you a time delay, but again, it's exactly the same attack, right? We're using substring. The only difference is when it gets the right letter, we wait for a specific amount of time. So that attack takes even longer than the blind attack because when we actually hit a letter, we're waiting for a bit. So we'll use this to cause a 10-second delay and solve this lab. And did it say where so it is in the tracking cookie again. So we'll go down to time delays here. And so in this case, this is using stacked queries, which we can always try. So we can try that. We could actually refresh the page because the tracking cookie was set in the first request. So repeater. So there's the tracking cookie. Again, I am gonna URL encode as I type. And we can try and end the query and then just do a wait for delay. So The example was wait for, but we'll see. So you should just be able to do a wait for delay. This is MS SQL, by the way. So 10 seconds. Let's do that. So Burp has a timer down here. So this took 138 milliseconds. It was rather obviously not a 10-second delay. So that's probably not it. So there's other ones we can do. Select PG sleep. So we'll do that. So PG sleep is for Postgres. That looked like it was going to do it, but it didn't. Oh, it actually did, because I typed 1 instead of 10, so I think this is actually it. Yeah, this is definitely it. So this should solve the lab. Done. Yeah. So that was an example of a stacked query, where we actually ended the last query and then started a completely new one. Okay. So again, this is just information retrieval with time delays. Exactly the same kind of concept as a regular blind SQL injection. Do you guys want to see any of the out-of-band stuff? This is like kind of advanced stuff. If you guys want to see it, let me know now in the chat. Otherwise, we can move on to server-side request forgery. I'll let you guys decide. Only if it's in the scope of OSCP. Really? Yeah, no, this isn't. To be honest, server-side request forgery is not in the scope either. What is out-of-band injection? So sometimes there's two ways of describing it. So out-of-band and super blind SQL injection. So generally speaking, the three major types of SQL injection are the ones where you can return the output of a query to the screen. So for instance, error-based or stack-based sometimes, or union attacks, right? Where we were seeing the content of the database in the HTML code. Then there's blind SQL injection, where you don't get that returned, but there's still an indication that something's going on. So for instance, you get an internal server error, right? If the SQL injection fails, and that's because the database caused an error, the web application didn't know how to handle it, so it just spouted an error page, like a generic one. And also the time-based attacks. So you're not seeing anything on the actual page itself, not even an error message, but the fact that it took 10 seconds to return means that we were able to sleep the database for 10 seconds. So the third type is super blind, or it has, as Portswigger described it, out of band. And what that means is there is no indication from you sitting at your computer that an SQL injection has occurred. Okay, it doesn't return anything to the HTML. It doesn't cause an error message. It doesn't cause a delay. It's processed completely asynchronously. But what you can do is you can trigger a separate request in the database. So databases are quite complicated, especially MS SQL ones. But basically, if xp_dirtree is enabled, what that does is it tries to connect to, I believe it tries to connect to a share on the network, right? And in this case, you can get it to try and connect to a remote server, which it probably isn't going to do for firewall rules, but what always happens is a DNS request, right? So a DNS lookup will occur. So yeah, you could describe it as MySQL SSRF or SQL SSRF, I guess. But it could be as simple as just a DNS request, you know. And so that shows that you've been able to at least inject into it. These are, and that's why they're super blind, is because unless you have that server running, and you would use Burp Collaborator, unless you have that server running and listening out for these requests, you can completely miss them on a test. The SQL injection I was talking about earlier, the one where I had to do it manually because SQL map couldn't do anything, that was a super blind. So I found that in the wild. Honestly, I consider it the best finding I've ever had in my career. Just because not only was I able to actually exploit it, it was so bad I was able to actually get remote command execution. So yeah, via a super blind SQL injection, which, is kind of like, when you're talking about web apps, that's like right up there. That's like one of the top things you want to be able to do. So, maybe one day I'll write a blog post, or I'll explain a bit more detail about it. But yeah, it's pretty cool. It was a pretty sweet vulnerability that I found in a live web app. So yeah, I mean, it seems that most people seem to want to see the SSRF, so that's fine. And again, like was it Mojo who said that? It's basically SSRF for SQL. Okay, so SSRF is up here, I think. Nope. There it is. So yeah, I kind of just explained what SSRF is, but it is effectively making the server, specifically the server, force it to do some kind of request, right? Now that could just be a DNS lookup. It could be an HTTP request, most likely an HTTP request. It could be to a remote server. It could be to an internal server. So they're becoming increasingly common just because web apps are becoming far more complicated, and there's so much stuff at the back end. It used to be that maybe there would be a web app talking to a database, but now you have a bunch of freaking stuff at the back end, all talking to each other. A lot of it uses HTTP, which means that you can do SSRF attacks against the back end. So basic SSRF against the local server. What we'll be using for this is a plugin called Tabulator, which is effectively, it's like it's a built-in version of the Burp Collaborator server, which usually you would get to here. Instead, you can just create payloads here, and they list them. And the reason I like this is because it preserves between sessions. So if I was to save my work in Burp, which you can do in Pro, it saves all this stuff. Okay. The lab has a stock check feature which fetches data from an internal system. To solve a lab, change the stock check URL to access the admin interface at localhost/admin and delete the user Carlos. Okay, so it has the stock check system, which is here. Let's check the stock of this roulette drinking game. And we will send the request to repeater. Okay. So if I hover over that, actually that's not good. Let's convert. Let's decode that. So this is basically the URL we're currently on is this, right? So ACD blah blah blah. So it's talking to something at the back end, stock.welikeToShop.net on port 8080. Product stock check, product ID equals 1, and store ID. Okay, so that's actually sending a request. Oh, yeah. So that's sending a request to the backend at that URL, and it's returning 621 to the web server, right? So the web server makes this request to this URL. It receives the response. This could be a direct response. right? Or the web server could be parsing the response from this URL and then sending this back. This doesn't have to be direct. I think in this case it's direct, but we'll see. So let's try just going to localhost. And it looks like that worked because we get, I believe this is just the home page. Yep, okay. And the way this is set up, they have, you see I get home and account login, right? The way this is set up, the admin panel requires either authentication or if the request is coming directly from the backend, right? So it's got some IP filtering possibly to determine whether, or if basically saying if you access the admin panel locally, then it'll show up without authenticating. So the admin panel is at /admin. So if we scroll down, actually let me render it. So we're able to browse to the admin panel, and we have these 3 links. These are all delete links. Now, this is a separate vulnerability. So this is just doing GET requests, right? It's just doing a GET request. Ordinarily, you would want any kind of functionality like this to not only be a POST request, but also include some stuff like cross-site request forgery protection, which this doesn't either. This is a GET request. So we want to delete, I believe, the user Carlos, right? Yep. So in this case, all we need to do is copy this and add it to the end there. And effectively, it's redirecting us, but we just deleted the user Carlos. Okay, because that was all that link did. You click the link as an admin, and it deleted the user. So that's like 2 problems right there. The fact that you could actually even get that to make a request, and the fact that it only takes 1 click, 1 accidental click to delete a user. Okay. Attacks against other backend systems. So that was against localhost, right? That was against the actual server itself, just coming from an internal perspective. So this lab, it wants us to scan the internal range 192.168.0.x for an admin interface on port 8080, then use it to delete the user Carlos. So we'll do the exact same thing. Go back to proxy. Okay. So what I'll do is we don't care about any of that. It said an admin interface, so I'm guessing it's going to be /admin. I'll encode that. What I'll do is send this to intruder now. It said on port 8080. Okay. So basically, we want to fuzz this parameter. So we want to try and explore other parts of the internal network. So I'm going to clear this out. I'm going to change this. I'm going to make a position out of it, and then we just want to select numbers. So we want to go for 1 is already in there, so we'll go from 2 to 254, and we'll step up by 1. And I always set these because sometimes Burp will try and put fractions in there. So in that case, that should stop it. And then what we're basically going to look for is either instances where we get not a 500 or length instances. And I think in this case it's going to be both. So if I actually filter out 500s, we get 1. And so it's on it's on 192.168.0.35. Okay, so we're going to take this back to repeater. And 35. And it looks like, yes, yep, we're in the admin panel, right? So we have the users, so we need to delete Carlos again. So all we need to do here is copy this, put it at the end, and it looks like that worked. Yeah, so we just deleted Carlos again. That time that was exploring the internal network. Common server-side request forgery defenses. So you can blacklist. I should really now use the term deny list. We should deny list based input filters. So you, for instance, if the URL is expecting to go to 127.0.0.1, you give it, expecting to go to some domain, and you're not whitelisting that domain, but instead you're deny listing other IPs, so for instance localhost IPs, then you might be able to block server-side request forgery. But if you're just deny listing either like localhost or 127.0.0.1, there are ways around that, as we will show. Yeah, block list works as well. I think I've heard allow list and deny list as the new ones that people seem to be getting behind. I guess allow list and block list works as well. Okay, so let's try again, just doing localhost 80. So we'll try this. Eternal stock check blocked for security reasons. So it's detected I'm trying to get to localhost, and it said, okay, that's not on the list, so I'm gonna, oh sorry, that is on the list of the block list, so I'm gonna deny that. So we can try and do 127.0.0.1, and again we get blocked. So this is something that I think not too many people realize about IP addresses, specifically, is this is just a representation of a 32-bit integer. Okay, it's just separated into these octets. So you can actually just Google IP address converter, and I think this is the one that was pretty good. If you type 127.0.0.1 into here, you can get not only an integer that represents, that basically is the representation, this is the integer, you can get that in hex as well. So if we copy this, I don't know why I just got rid of that, and put it in there, could not connect to external, maybe it's just on that port. Yeah, okay, so it wasn't 8080, it was just the regular one. But if we scroll down, there's the link to the admin panel. We go to /admin. Okay, external stock check blocked for security reasons. Try, okay, yeah, I'll try that. 127.0. Hang on. 0.0.0.0.1. Well, hang on, let me do this, because I think it's the admin that's triggering it. Yeah, that works as well. Also, if this was not in a restricted environment, there is, I believe, localtest.me. That's funny. That actually went to my internal server. So localtest.me, I will Google it because there is a README. Localtest.me. Every subdomain of this and localtest.me itself resolves to 127.0.0.1. So you could, if you're in a real-world engagement, use this. I actually managed to turn an external SSRF into an internal SSRF using this about 3 weeks ago now. So I love this site now. It's great. So, but it looks like as soon as we type admin, we're getting blocked. So let's go back to the page with the blacklist filters. You can use URL encoding, right? So, or case variation. So maybe admin works. And it looks like it did. So in that case, it's obviously filtering just the string lowercase admin. Something else that works, because this is getting parsed by the web server itself, and then it's being reissued as a request, what you can do is you can double encode this URL character here. So if we convert to, if we go all characters, and then if we do it again, because if I just send this, right, the server's going to decode it to an A and it's going to get blocked again. But if we encode it again, encode all characters, I believe it should work. Yeah, so it works. And the reason that works is when the web server receives this, let's just paste it in there and decode it. This is what it gets decoded as. So it decodes that. That's what the web server sees, and it says, okay, is the word admin in there? No, that's not the word admin. That's %61 dmin. And so it says that's a perfectly valid URL, and then it sends that as a request. Well, because it's just sending it as a request, %61 automatically will get decoded again when it reaches the second web server into an A. So that's why that works. So let's delete Carlos again. Poor Carlos. It's effective here. It really depends on what's happening. The only reason it's effective here is because you're using two web servers, and the first one is decoding it once because that's what web servers do. Web servers will always URL decode once, at least once, I should say. So the first web server, which is this one, is decoding this string because that's how it operates. That's what the spec says to do. It says to decode the message just in case there was any encoded characters. And then when it sends this, when it connects to this URL, it's sending an already encoded letter to that URL. So when it hits the second web server, that web server decodes that, and that's when you get the final full URL like that. So it's effective here only because we're going through two web servers. So if I was to actually triple encode this, so let's triple encode it because this probably won't work. Encode all characters again, and I'll take out the delete. Yeah, not found, right? Because after two decodes, it's still got some encoding there that it doesn't recognize as an actual file path. So that worked. Okay. Okay, SSRF with whitelist based input filters. Allow list based. Should write a letter. Oh, this is an expert one. Interesting. Okay, so let's try it. Check the stock again. Okay, so let's just go back and read over. It's anti-SSRF again, and it's whitelist based. So basically, we have to try and create some URL that's going to reach localhost. So let's just try and get something basic working. Let's take this because it's probably extracting the host name at some point. Let's just see if we can get to that. Could not connect, but if I put 8080 in, oops, it's going to be fine. Missing parameter. Okay, so it's definitely working on that. What we might be able to do is, can we do .localhost? External stock check host must be stock.weliketoshop.net. Okay. So one thing you can do, which I think it mentions, is you can try and trick the parser into thinking that this is the host when actually if you put an @ symbol in it, it's technically credentials. So another thing that not, I guess, too many people realize is that URLs can include credentials by the schema. So you have the HTTP scheme here followed by an optional set of credentials, which are usually of the form, so username, password at hostname.com, right? So that's technically valid. It's obviously silly because you're sending the username and password as part of the URL, which is like a no-no, so don't do that. But let's see if that will work. It doesn't look like it will. I wonder... it also says you can use the hash. So we can try and use the hash. Now obviously if you just put a hash there, that's going to be a URL fragment. So what we really need to do is encode that. So we'll encode it. Code all characters. Okay, that's good though. Did it say... Okay, so you can flip this. So actually we would put it this way around. That makes more sense because it's thinking that this is part of it. No. I wonder if it is 8080. So if I put a fragment in there, okay. Just want to see how this does it again. Missing parameter. Yeah. Okay. This is a tricky one. Nope. Localhost didn't work, did it? Yeah. So we do need to try and trick it into connecting. That's not liking that. So I do feel like it's got to be... So I wonder what happens if we do this. We know the location is that. Could not. Okay, so it's this one. Yeah. Okay, so it's still not doing that. Localhost, percentage 23. This is a really tricky one. That's why it's expert. I think I might just look at the solution, honestly. Okay, so it was double encode, right? Okay, we were like almost there. So I think effectively it was, what did it say? It was double encoding. Right. So that was all we were missing here. We needed to double encode this. And then put an at. Yeah. Okay. We were almost there. I just forgot to double encode. So now I think if we do that, right? Yep. So we'll delete the user Carlos to complete that one. But yeah, that's why that one's so tricky. Okay. Open redirection. We can try this one. So this is where if you have another redirection on the server, you can use that as part of the SSRF. Stock tracker has only been restricted to local application. You need to find open redirection affecting the application first. So what we'll do is we'll look. I'm going to look for 300s. If I go to account login, maybe test. No. There's a 302. Okay. So we have a GET request that has this path in it, and the path will basically send us to the location. So what we want to do is, where's the stock check? There it is. Send that to repeater. Copy this. And so now if we need to URL encode all of this, so we're basically going to try and get it to redirect to product ID 2. All characters. Nope. Haha. We are going to URL encode key characters and send it. And is this product ID 2? Let's just check. ComTool. Okay, I'm just going to render it to make sure. So what happened there was the request went to this redirection instead, and the redirection redirected the server again to the ComTool page. So what we can now do is we can redirect to the admin page, right? So we can do path equals admin here. So this is all URL encoded still, but we're basically redirecting to admin. Looks like not found. So let's just double check. That's interesting. So admin was there. Is there any clue here? Ah, okay, the admin interface is there instead. So in this case, it's probably not the path that we need. It's probably, we want to redirect to that. Yeah, okay. And then we'll delete the user Carlos. Okay, so that was just me not reading the instructions. Not found again. That's interesting. Did it? We did solve it. Okay, so I'm guessing that was something to do with the back end. Once you've deleted the user, maybe it redirects somewhere that it can't go to. But that was definitely solved. So, and blind SSRF, we did this back in the XXE, so that was technically an SSRF. I think maybe. And let me just double check. I'm just going to view all labs. Let's go down to the SSRF. Okay, we haven't solved them all. Out of band detection. So maybe we'll finish off with this one. Because this uses the collaborator, which I talked about before, but we never really used, so I figured this will probably be a good idea. The site uses analytics software which fetches the URL specified in the referrer header when a product page is loaded. Okay, so let's load a product page. View details, go to the proxy. This is the product page. It's going to load from the referrer header. So what we'll do is we'll go to Tabulator, create a payload. We will stick it in there. And then hopefully if we poll now, yeah, we get a DNS hit. Okay, so that's all that one was. So at the back end, again, this is asynchronous, so it's happening separate to this request. It's not returning anything to this request, but it's fetching, or it's at least doing a DNS lookup. I wonder if we can actually make it do an HTTP request. We can. How does the collaborator work? So it is technically hosted on burpcollaborator.net. It has an authoritative DNS server. What that means is that if you ignore any caching, any DNS request to a subdomain of burpcollaborator.net will always hit that DNS server. Okay, so the idea is it's the only DNS server that knows where subdomains of Burp Collaborator are, so it's guaranteed to get a hit. The exception is obviously caching, right? So as soon as you have this address cached, you don't have to. That's why we got a DNS request initially. I used HTTPS, that's why it didn't work. So I used the DNS request initially, and then we got an HTTP request without a DNS request. So if I was to create another payload and put it in here with HTTP instead of HTTPS, and now we should get a DNS request and an HTTP request. They don't come in that order. The timing is off, but the DNS request obviously happens first. So what it is, Burp Collaborator is a DNS server. It has an HTTP server, it has an HTTPS server, and it has an SMTP server for receiving emails. And basically when you click Create Payload and Copy, Burp will contact the Collaborator server and get a payload and register that payload. You can then use that payload in requests, and what this poll basically does, every 60 seconds by default, it's going to check with the Burp Collaborator server, okay, was there any hit on this payload, whether that's a DNS request, an HTTP request, or an SMTP. And Burp will tell you, yeah, okay, all these payloads were triggered in these various ways. Here's some information about it. So in this case, you probably can't read this, but it says the request was received from this IP address, right? So yeah, you can set up a private collaborator server, which we do at our work, mostly because we don't want to be sending customer, or making customers connect back to Burp Collaborator that's not controlled by us. So I know some people use, especially in bug bounties, obviously you probably use the public one. The public one's available, I think, only for members of Burp Pro. So, but yeah, did that? That did trigger. Okay, so we solved that. So yeah. How do you figure out what extensions for Burp Suite are useful to get and use? Honestly, it's a process of trial and error. There are these aren't even all the extensions that I use on a day-to-day basis. There are way more. I just disabled a lot of them because it just ends up looking crazy. But you can go into Extender and you can go into the BAP store and you can just, I would say sort by rating and by popularity, and install them, play around with them, see what works best in your workflow. I've got, look at all the ones I have installed and like half of them don't even appear up here. So it's mostly just, getting to know them, using them, seeing what you like, and going from there. Cool. All right. So we won't end the stream right now, but I'll put the thanks for watching screen up. How do I feel about manual enumeration? Manual enumeration, like, how? Like, actually manually, like in the browser? I take it with web console, you mean like JavaScript stuff. In which case it's annoying, but you have to do it occasionally. I try to use as many tools as I can, just, because tools just make our lives a lot easier. Yeah, I do it as part of my my day job. I'm probably not a bug bounty wizard in that respect. I don't like the network tab. I prefer to use Burp for that. Anything networking relating is going to go through Burp, right? Even if it's initiated by JavaScript, it's going to go through Burp. There's nothing stopping that. But in terms of, you can, click a form and think it's going to send a certain request, and it doesn't because it's been intercepted by JavaScript. JavaScript's done some stuff to it, and you're like, okay, I need to investigate that more, and that's when you have to get into the developer console. I'll probably cover that to a certain extent in the course that I'm writing, specifically using the debugger, because Chrome and to a certain extent Firefox have a really good JavaScript debugger. So it's kind of useful just stepping through the JavaScript process. But it's becoming increasingly more difficult just because a load of web apps now have a ton of JavaScript to do a lot, especially if you're talking about single page web apps where like a lot of the functionality is in JavaScript now. So it's definitely getting more difficult. Any other questions before we go? I am happy to answer a few. They don't have to be about what we just did. They don't even have to be about web apps. Cool. I guess not. Okay. In that case, yeah, like the screen says, thanks very much for watching. I hope you enjoyed it. Please follow me on Twitter. Join my Discord. Give me a follow on YouTube, and obviously, if you can follow me on Twitch, that would be great as well. So yeah, I'm gonna call it Discord from now on. Yeah, thanks very much, guys. It was great fun. And I'm glad you all enjoyed it. Alrighty. Everyone have a fantastic weekend. Alright, see ya.